Hey everyone! Alright, so we're going to be modeling multiplication problems using arrays today. Yesterday we were doing our threes by skip counting. It's a fine method, it works great, but sometimes we don't know all the numbers in that sequence, or maybe we're thinking about a problem that we can't skip count. An array is a nice strategy that will help you with any multiplication problem. So let's take a look at what an array is. The first thing I'm going to tell you is an array is a very organized picture. Okay? An array is a picture that shows equal rows divided into nice equal columns. I like to tell people it's like a picture in the army. Hut, 2, 3, 4, march in a line, hut, 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 right? So what I have here is I have 5 threes. 1, 2, 3, that's 1, 3, right there. 1, 2, 3, that's 2 threes. 1, 2, 3, that's 3 threes. 1, 2, 3, that's 4 threes. 1, 2, 3, that's 5 threes. So when I do an array, I look at the problem and the first number tells me how many I need. In this case, I needed 5. 5 what? Well, 5 little threes. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. None of them can be 4s or 2s or 6s. They all have to be the same. Repeated addition, right, is multiplying. That's what it is. So it has to happen over and over again exactly the same way, many times. And then the answer is right here. I've already got my answer. It's just given to me in dots, and I have to count the dots. So I can count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And there's my answer. My other choice, if I knew how to do it, would be to skip count by 5. 5, or I should say skip count by 3. 3, 6, 9, 12, 15. I get the same 15 whether I'm counting by ones or I'm counting by threes. Now, the interesting thing about multiplying and arrays is you could imagine this problem flipped very easily, right? That's one of the things you can do whenever you're adding or subtracting is you can just flip the problems and it doesn't change the answer. But it is going to change the model of the answer. Let me show you what I mean. So here is a very different array, right? I don't have 3s and I don't have 5 of them. Instead, I have 1, 2, 3, 4, 5. Okay, so I have 1, 5. And then right here I have 1, 2, 3, 4, 5. Okay, so I have 2 5s. 1, 2, 3, 4, 5. Okay, I have 3 5s. So in this case, I have 3 5s. Now, 5 threes is the same thing as 3 5s. The same answer. The only thing that's going to be different is I was standing up tall, right, with short little rows when I was doing the top problem, and I'm kind of lying down a little bit now, and I have longer rows, not as many of them. Here I have 3 5s. Here I had 5 3s, but my answer is exactly the same. Now, with all of that said, how can dot paper and arrays help me solve multiplication problems? Well, I'm glad you asked. So, the nice thing about dot paper is the arrays are already done for you, right? I've given you a million dots. They're all spaced out perfectly. But the problem is you don't need all the paper I give you. You only need 4 rows. So if you're going to use normal dot paper, you might have to limit or rip off or circle just the dots you need. Don't use them all, because if I just counted all the dots, I'd be counting all day, number one, and I wouldn't necessarily have the answer to my problem, because I only need 4 of these groups of 3. So I need 1, 2, 3, 4. How many groups did I need? 4. The rest of these I don't even need. They are gone. Okay? So now I have my answer right here. I just have to count it to find out what it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The answer is 12. The other strategy that we learned yesterday would be to hold up 4 fingers and count, skip count. 3, 6, 9, 12. Both strategies work. This one is nice if you don't know your skip counting. It works for any problem. You could multiply anything with dot paper. It might take you a little bit of time. So someone says 7 3's. Well, maybe you don't know all those 3, 6. Oh, I don't know them all. But I could count that. Yeah, I just have to count it. I need 7 of these. 1, 2, 3, 4, 5, 6, 7. Rip it right there. Throw that part in the garbage. My answer is right there. 7 3's is my answer. All I have to do is count for it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. The other thing I would suggest about having a couple different ways to solve a problem is sometimes it's nice to double check. You know, try it both ways. If you get the same answer both ways, you probably got a pretty good answer. 3, 6, 9, 12, 15, 18, 21. Look at that. I got 21 and that's what I counted. When you're doing a lot of counting, sometimes if you're not careful, you might have accidentally got a 20 here or a 22 here. You know, maybe you missed one or you counted twice or something. So it's worthwhile to have a double check or another method to lean on just in case. So if you were here, I would ask you what happened. I thought we were doing 3's, right? This is a very tricky problem. So what happened is they flipped them on us. So instead of 3's, I need 5's. 1, 2, 3, 4, 5. So I only need 1, 2, 3 5's. So I just count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Tricky one, Mr. W. What in the world? And then let's see what the last one is. Oh, you can do story problems with dot paper as well. There are 4 hens. Each hen lays 3 eggs. How many eggs do they have in all? So I need 4 3's. So I could go 3, 6, 9, 12. Or I could go 3, 3, 3, 3. All these are trash. There's my answer right there. Just have to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, this equals 12 eggs. You know, dot paper is one method. Skip counting is another method. They're both good. So today, you're going to do a story problem right here. 6 3's, and you're going to use the dot paper to count for your answer. Or skip count for your answer. Here we have 7 3's, and you're going to use the dot paper to figure out how many wheels are on these tricycles. Here you're going to have 8 3's, and you're going to figure out how many kids are in the groups, right? There are 8 groups of 3. How many kids are in the whole class? Use the dot paper to help you solve. Once you get really good at it, right? I'll give you some dot paper on your Seesaw page to work on, but we want you to go ahead and solve the problem once and then flip it and think about it the other way too. So see how they're taking the dot paper once, so they have 4 3's, and then they flip it and they have 3 4's. Same thing, because 6 3's and 3 6's both give you the same answer. So all of these are going to have the same answer. The only thing that's going to be different is take a look at number 9. It'll show you exactly what they're doing. They are flipping the 2 different numbers at the beginning. Right about here is the last of the work I want you to do. Then you're going to switch to the math game and practice for me there. Thanks, guys. Bye.